So I'm going to very quickly talk about Project Squirrel, which was mentioned earlier. So this is just a side project we're running at Spaceflight. And essentially it's seeing, can we replace all the conventional circuits we're using in a flight computer with an Android phone, such as this Nexus 1? As evidenced by this picture, the answer is yes. So it's not going to work. Can you just click next?
Yeah.
So Google have given us this phone after a sort of proof of concept launch, seeing what can we make it do. So obviously it's got a camera on board, which is really useful. It's got lots of sensors, which it's nice to log. That is on the moon, yeah. Didn't quite get that there. And then there's the issue of, can we actually make it transmit its location? So of course it can't by itself do that, but we found that if that's an NTX2 soldered directly onto a 3.5mm headphone jack, and if we connect that directly to the headphone socket and then create the audio tones through an app, it magically works. So we're not sort of keying a high-low on RTTY, we're actually generating the audio directly, and so it all works fine. So that's the only external component we have to the phone. It then transmits as normal. We can then do SSTV directly from the camera. So that was a test. Like I say, we weren't actually taking photos on this one because I was piggybacking on one of James's boxes without a window, so I just preloaded a few photos of what I thought we might get if we...
So that's SSTV transmitted from the phone?
That's transmitted from the phone. Just really to
it's over FM though, isn't it?
Yeah.
Yeah. Well, that's because you have to download things,
So that's that. And so we have apps running doing camera video stuff. It logs all the sensors, which I think are doing.
How are you powering the NTX2? Is it powered from the phone?
No, it's not. So it has its own battery. What we could do actually is get a
USB,
power from the USB. We figured it wasn't really worth it for that test. And can we get the next slide? So it has some nice graphs and stuff. Just, you can log lots of accelerometer stuff. Probably not very accurate. There's another gives us magnetic field data. If anyone can explain that anomaly there, it's flew very close to an aircraft or something with a big magnet. I'm not sure.
You sent yourself to send it up? You sent it up?
Yeah. So I've got the background there. The actual altitude.
Which axis magnetic field is that?
This is just magnitude. This is magnitude. I only plotted these quickly the other day, because this was one that was stuck in a tree for 4 months. So this plane recovered fine.
Well, you got it back?
So we got it back to on Monday after hiring a tree surgeon.
But it landed in a tree the first time round as well.
Yeah, so it's called Project Squirrel, so we've rebranded it Flying Squirrel. So it might escape the next time. I think there's one more graph as well. It's got internal battery temperature, which is a nice little thing there, which we can try and work out exactly what's doing. So that's kind of that, and there's lots of new exciting stuff we can try to do. For example, put 2 phones, create an ad hoc wireless network and let them communicate between each other on 2 separate boxes. And lots of proof of concepts we can try and do.
What the phones are costing you a small fortune, aren't they?
Well, we've got Google, so anyway, and then we think, can we go any higher? Oh no, in fact, here's do a quickly play video if you want, but that's this was just recorded from this last launch. It all works fine. There's a few bugs in the Android recording media framework that sometimes make it hang.
Is that what you have to?
Sorry?
Is that what you have to? Bugs
So, and then on the next slide, it's just sort of slightly off topic, but I'm saying, can we go higher? The answer is yes. You may have heard Siren Satellite Technology Limited launching a satellite which is being eventually controlled by a Nexus 1. We submitted a proposal for an actor on this, which has been accepted, which is very silly. It's called Screen in Space. We're going to let people submit YouTube videos of themselves. It's essentially an outreach project, a bit like Robert's been talking about. It's a scientific experiment to test the hypothesis that in space no one can hear you scream. So with some tenuous science links anyway. So people are going to record videos of themselves screaming, and then there's going to be a voting system for the most creative ones, and then the top 20 or so are going to be loaded onto the satellite. So it's a CubeSat. It's now going to be sent into orbit. There's going to be a phone here. They're going to play on the video, and then there's going to be a camera facing this, recording it. It'll be downloaded back to Earth and put on the website and they see. So the tenuous bit is the fact that the microphone's actually on the phone itself. So mechanical coupling between speaker and microphone is going to be significant, but that's we can't do anything like that.
Will you actually be able to see space in the background outside of the screen? Or?
Well, the point was so we can then be filming through the camera as well. I don't think you'll be able to see the phone.
Oh, okay.
Through, but what I mean, we can record it. We'll have a bit of it showing on the screen through the camera. That's the project next, and that's going to be launching in summer 2012. So that's very quickly. What's this?
Are you going to directly use some of the stuff you've done for your on the CubeSat?
Yeah, so we have some extra capacity as well for the video
so
stuff.
Can we? This is what I really want to do: is implement a UKHAS standard transmitter on a CubeSat, and then we can track it with FLDG. It would so work.
Check it on Space Earth.
You see SSTV off the camera on the phone. It would so work.
Yeah, we've got some meetings with SSTL stuff like that. We can check that.
Look, we've got a free NTX. Yeah. We can give you that.
If anyone's got any questions, just catch me later. Or yeah. Any questions there? Thank you.
Thank you.